basic probability. Alright, just thinking about definition of probability first. Probability is of an event is the likelihood that it will occur. Seems pretty basic, right? Probability is usually going to fall between, or is always going to fall in between 0 and 1. If the probability is 0, is it going to happen? No. If the probability is 1, is it going to happen? Yes. If it's anything in between there, it might happen. If all possible outcomes are equally likely, the theoretical probability of an event A is, here's how we write it, so we say P of A, probability of A, is the number of outcomes in A, this is like its technical definition, over the total number of outcomes. It's like number of things you're looking for out of total is kind of how I think about it. Usually I leave my answers as a fraction. I believe in stats they write them as decimals, but that just is like an extra step that I just skip. Example, some very basic example. Probability of flipping a heads on a fair coin. Okay, so probability of heads would be based on, is my pen dying? The number of, oh my goodness, my black pen is dying. Hold on. Okay, we would say number of heads out of number of total sides. That's how we would write it. How many heads are there? One on a fair coin. How many total sides? 2. And again, I usually leave my answers as fractions. You can also write it as a decimal, it'll be 0.5. Okay. Probability of rolling a multiple of 3 on a fair die. A fair die is always just talking about a regular old dice, not some sort of trick dice. So probably getting a multiple of 3 would be the number of multiples of 3 out of the total. How many multiples of 3 are there on a dice? There's 2, right? Because 3 and 6 are both multiples of 3. So there's 2 of them. Out of how many total sides? 6. 2 6 would reduce to 1/3. Doing okay so far? Alright. Odds are slightly different. Okay, so odds, it still uses a fraction. It's just what we're finding is a little bit different. The odds of an event are another way of thinking about how likely it is to occur. Okay, and there's usually 2 types of odds we talk about. The odds in favor of something happening and the odds against something happening. Okay. So the odds in favor of A, we would write that as the number of outcomes in A. Number of outcomes in A compared to, instead of total, we don't use total on this one. We compare it to the number of outcomes not in A. Not in A. Okay. And the odds against A, we basically flip this around. We say the number of outcomes not in A. That goes on the top. And then on the bottom, again, instead of putting total, we just put the number of outcomes in A. I don't know why I separated the out and comes, but okay, I did it. All right, let's look at some little examples. What are the odds in favor of rolling a multiple of 3 on a fair-sided dice. So if in favor of rolling a 3, on the top we want to put number of multiples of 3. Hold on. And then on the bottom we're going to put the number of not multiples of 3. So we don't care about total, we just care about which ones are not multiples of 3. Okay, so then going back to our dice, I already heard Mason say it. How many multiples of 3 are there on a dice? There's 2, because 3 and 6 are multiples of 3. So then, how many numbers on a dice would be not multiples of 3? 4, yeah. Which would simplify to 1/2. Very nice. It's similar, yeah. Okay. When rolling a 6-sided dice, determine the odds in favor of rolling a 4. So if we write out our thoughts, on the top we're going to put the number of 4s. On the bottom we'll put not total, but the number that are not 4s. Okay. How many 4s are there on a dice? There's 1. No. No. Fine, I'm just going to annoy Danny then. How many not 4s are there on a dice? There's 5 numbers that are not 4s on a dice. I'm okay with it. I don't like saying on a die, because then I just say the word die over and over and over. Okay, last one. Last one is not odds. What is the last one? Probability. Okay. Remember, probability involves using total. Okay, so we're going to say number of 4s out of number of total sides. How many 4s are there? There's 1. Out of how many total? There's 6. That one does not reduce. All right, survey of 320 students in Carnegie shows that 240 of them listen to the radio station 97.9. Do y'all? Is that still a station? Is it still a station? Okay. Okay. Yeah, I listen to a lot of podcasts. Let's see what it says. It says, find the odds against randomly selecting a student who listens to this station. Okay, so if we're doing odds against, what do we want on the top of our fraction? The number that don't listen. Good. Don't listen. And then what do we want on the bottom? The not total. Total is probability. The number that do listen, right. God, all these grammar Nazis today. It's die. Where's your apostrophe, Mr. Brody?
It's annoying to hear it because I notice it now because
Okay. So if there's 320 total and 240 of them do listen, how many don't listen? Right. You take your 320, you subtract 240, which means 80. And then the number that do listen, we already know is 240. Does 80 over 240 reduce at all? Yeah. 1 to 3. Yeah. What do you mean the normal way? This is the normal way to calculate it.
Well, that's a lot of things. It's just a third of them that don't.
All right, we got our card questions. Those are easy. Where did I put my information about cards? Here we go. Here's our card info. All right. Infamous gambler, Amarillo Slim. They're drawing a card from a standard deck. When they say standard deck, they're saying it's not a trig deck. We've just taken, there's no jokers in it, nothing weird about it. We are calculating odds on these, so not probability, so we don't need our total. Okay. When it says odds in favor of it being a 10. So on the top of our fraction, we're going to have the number of tens. And on the bottom, we'll have the number that are not tens. Good. Okay. How many tens are there in a deck? There's 4. There's one of each. There's one that's a heart, a diamond, a club, and a spade. There's 4 tens. So the number of cards that are not tens would be 48 cards. And then a little simplifying would give us 1 over 12. The next one's saying odds against it. I'm just going to highlight all of those. Okay, against it being a face card. So on the top of our fraction, we're going to have the number that are not face cards. And then on the bottom, we'll put the number that are face cards. Face cards are going to be the Jack, Queen, and King. Okay, Jack, Queen, and King are face cards. So there's 3 face cards in each of these suits. So how many total face cards are there? There's 12 total face cards, right? So on the bottom, we'll put 12 total face cards. So if there's 52 total cards and 12 of them are face cards, there's how many that are not faces? Yep, 40. That does reduce a little bit. 10 to 3. Odds in favor of it being a heart. So since it's in favor of, we'll put the hearts on the top. Number of hearts. On the bottom, we'll put the number that are not hearts. There are. Good job. There's 13 hearts. 52 minus 13 will be the number that are not hearts. 39 cards are not hearts. That does reduce beautifully again. 1 to 3. And then lastly, odds against it being the ace of spades. So on the top, since it's against it, we're going to put the number that are not ace of spades. And on the bottom, we'll put the number that are ace of spades. I already heard Honor say it. How many ace of spades are there? There's only 1 ace of spades, yeah. 51 to 1. Barely fits. Got it though. Alright. Next one's going to be a little challenge. Carnegie Glee Club does karaoke one night. Do we have a Glee Club? No. 7 of them are scheduled to perform. The order of them is randomly selected. What is the probability? Okay, so this involves probability. So probability, remember, has to do with total. What is the probability that the musicians perform in alphabetical order? Assume none of them have the same last name. Okay, so thinking about that. On the top, if we're doing probability, we need number of alphabetical orders. And on the bottom, we'll need just the total ways they could perform. 1 second, we'll get there. Total, that's not it. Number of total ways to perform. All right, let's talk for a second. How many alphabetical orders are there? 1. There's only 1 alphabetical order. It's alphabetical order. Yeah. There's also reverse alphabetical order, but that's not a thing. It just said alphabetical order. There's only 1 way that everyone could go in alphabetical order. That's sadly how alphabetical order works. There's only 1. So I know on the top is 1. It didn't say reverse alphabetical. It said just alphabetical. Now on the bottom, we're going to have to think, how many ways are there for 7 people to perform? 7 factorial. There are 7 factorial ways that 7 people could perform. Very good. That was good, Rashida. Good, yeah. So on the bottom, we'll just need to figure out what 7 factorial is. Anyone evaluating 7 factorial? 5,040. So, is it likely to occur?
Yeah.
It's 1 out of 5,040 probability. So, it's possible. It's not 0. But it's more than likely not. Okay. Experimental probability. I know this sounds like it's something different, but it's actually very similar. The only difference between experimental probability and theoretical probability is experimental probability is when you actually do an experiment and get results from it. Yes. These stupid kids sleeping today. Okay. In a survey of 200 adult customers at a mall, 122 said that they wear jeans more than 3 times per week. 56 said they wear jeans at least once a week, but less than 3 times. And 19 said they wear jeans less than once a week, and 3 weren't sure. What is the probability, so we know we're going to involve a total, that one of the customers in the survey said they wear jeans once or more a week? Probability of getting once or more a week. Okay, so probability, I can't even see what I'm writing. Okay, probability of once or more. So on the top, we're going to put the number of people that said they wear jeans once or more. And on the bottom, we'll put the total.
I thought it was a trick question, and it was just like, what is the probability that someone in this is like not answering just taking something?
There are several people that did say they wear it once or more. So starting with 122 said they wear jeans more than 3 times a week. Should we include them? Yeah, because that would be once or more. 56 said they wear jeans at least once a week, but less than 3. Should we include them? Yep. 19 said they wear jeans less than once a week. Should we include them? No. 3 weren't sure. Should we include them? No. So we really just need to include this 122 and this 56 out of the total of 200. 178 over 200, which is simplifying to, it just divides by 2. 89 over 100, which is a perfect 89%. Bailey, can you have Amari lift his head, please? Encourage him to. Thank you. That's some good encouragement. Amari. No. Alright, geometric probability, it sounds scary, but it's not. You're still just doing probability. Looking at our only one. What is the probability that a penny randomly dropped on this rectangular board hits one of the triangles? Very good. So since we're looking for one of the triangles, we need basically the area of the triangles out of what? The total area. Good job. Okay. Total area is pretty easy to calculate. Total area would just be length times width of this rectangle. Okay. Yep, we'll need to add all those triangles together. This first triangle, how do you find area of a triangle again? One half something. All right, teamwork. All right, so this first triangle, if we do 1/2 base times height, what's its area? 1/2 base times height. 6. For this one, if we do 1/2 its base times height, what do we get? 20. And then the last one is the same as the first one, so another 6. 32 over 400. Which simplifies to 8 over 100 also simplifies.
4 to 50.
Which also simplifies. 2 over 25. There we go. Which is technically what percent? 8%. Alright. Let's say that's good percent. That's decent. I feel like there's games like this at whenever you go to the fair. Like throwing a coin into the thing.